Hello, good morning, everyone. It is my pleasure to be the start presentations for our reading group semester. Today, I will present a paper in NIHL 2019 titled "Lipstick on a Pig: Debiasing Methods Cover Up Systematic Gender Bias in Word Embedding, but to not remove them." The author is Joan Goldberg, very famous in NLP. Our presentation today has 5 parts. The first one is a brief introduction to word embedding. The second is I will talk about the gender bias in word embedding. The third one is I will give you some introductions to the famous to the methods in debiasing gender bias. The first part is some analysis about the debiasing word embeddings, and finally is a conclusion. So the first one is the word embedding. Everyone can very familiar with this. Word embedding is a popular framework that represents the text as a vectors. Word embedding will represent a word or a common phrase as a d-dimensional vector. There are two salient characteristics of word embedding. The first one is words with similar meanings will tend to have the vector close to each other. The close mean for example, the close is measured by higher cosine similarity. The second characteristic is the vector differences between the word embeddings show some relationship between the words. For example, man vector minus woman vector is very close to kings minus queen. However, previous researches have shown that when learning word embeddings, the embeddings pinpoint the sexism implicit in the text. For example, man minus woman is very close to computer programmers minus homemaker. This means that the problem here is they regard that computer programmers is for men and homemakers is for women. So, but in reality, both men and women can be computer programmer, and homemaker can be both men and women. And formally, in their research, Pollux-Bassi and their collaborator define that the gender bias of a word is defined by its projections on the gender direction. The gender direction here is he minus c, he minus c, and assuming that all vectors are normalized to unit length. And from these definitions, the larger word projections on the gender directions, the more biased word is. Based on the definitions I mentioned before, the author proposed some method to debias the gender bias in the word embeddings. The first one is the one of Pollux-Bassi in Neurips 2016. I will give you the general idea of this method. The first one, in this paper, the author tried to reduce the gender bias from the word embedding by they reduce the gender bias in word embedding as much as possible from the word that's not inherently gender. The word inherently genders like mother, brother, queen, etc. will not be included in the debiasing method. They do this by zeroing the gender positions of each word in a predefined gender direction. And also another step is the gender neutral words must be equally distant to the gender words. This is a detail of this method, so I will talk a little bit on that. The first thing is they a subspace is a subspace is defined by a k-orthogonal unit vector in d-dimensional, and projections of a vector v onto subspace b is defined by the weighted sum of the unit vector bj here, and the weight is the dot product between the v vector and the bj vector. So the debiasing method contains two main steps. The first one is to identify the gender subspace. In these definitions, this is more general than the gender bias. So the author choose the D1, D2, etc. to the end is a subset of W, which W is the own word of the vocabulary. So the definition here is general. General means that D1, D2, and Dn here can be the word with gender bias or the region-linear bias or something else. But in the scope of this paper, you can understand that D1, D2, and Dn is just a set with only one word, like man, women, brother, sister, etc. The word that is inherently gender. So they calculate for each test di, they calculate a mean vector mu I is the mu I is the average of the word vector belong to di and normalized by the number of elements in di. After that, they after to find the bias subspace B, they take the first k rows of single value decompositions of matrix C, and the matrix C is calculated using the formula here. So using the gender bias subspace B here, they do two things to generalize. Sorry, they do two things to debiasing the gender bias in the word embedding. The first is hard debiasing. In the hard debiasing, there are two steps. The first is neutralize, and the second is equalize. The neutralize. In this step, there is also additional input, which is the word to neutralize n here, and is a subset of w. For neutralize, they just the W here is the original vector learned by word to vec or graph or something else, and WB here is projections of W onto the subspace B here, and just the neutralize algorithm is just take W minus WB and normalize by the length of this vector to make the vector unit length. And in the next step is equalize. The equalize means we have an access of E to E here. E has is inherently gender worth to make it equalize to make the gender neural worth is equidistant to the genders, to the inherently gender worth. So the step is quite similar to the first one. The first step is just take the mean vector of the own of the word in the set E here, normalized by the number of elements in the set. Calculate the V by W minus the V is mu minus the mu B. Mu B is the projections of mu on the subspace B here. And for each W belong to E, calculate this vector. This vector is in the orthogonal subspace, and this constant here is just to make the new W is the unit length. So just take some illustration to understand of this step. The first is neutralizing. You can see that at first before neutralizing, X word will be represented in two-dimensional. The first is a bias dimension, and the second is a remaining dimensions. So before neutralize, receptionists have some component from the bias directions. But after neutralize the receptionist, the vector is orthogonal to bias dimensions. The next one is equalize. Is the first before equalizing the girls and the boys, they are two inherent gender words, but they have a different strong on the bias action by just take the vector here and take the vector here. So after equalizing, the projection of girl and boys on both bias dimensions are equal. This means that boy and girl, when we project on other dimensions, they also have an equal distance here. However, when equalizing, we can see that some the boy and the girl here have a equal distance to the non-gender bias dimensions. However, in natural language, there is some word with although they have an equal distance to non-gender bias dimensions, but some word need to be gender in some collocations. For example, you can see that in natural language, there is collocations mean to grandfather regulations rather than to a grandmother regulations. So in this context, we need to a word grandfather than grandmother. Therefore, the author proposed another method to overcome the disadvantages of hash debiasing. They call substance. The main idea of substance is find a linear combination T for gender neutral words that reduce the components, but do not move the word too much. The formula on the screen here, they choose this is a loss functions. There are two components in the loss function. The first is TW transpose multiplied by TW minus W transpose multiplied by W. This is this loss function to maintain that when we transform X word in the W by matrix WT here, it do not move the word too much. So remain as much as possible the characteristic of the word before debiasing. The second one is when we apply the debiasing method, so the projections of the projection of the word onto the gender bias here is minimized. So these methods have overcome of the disadvantages of hash debiasing. And another work to debiasing square embeddings is from EMNLP 2018. The main idea is they train the graph word embedding with different loss function. So let's come into this loss function. The loss function here have three components. The first one is the LZ is the original graph word embedding objective. The second is a JD. JD can take two forms. The first is L1 is the L1 and the LD. For L1, this means that omega M here is the word for the male and omega F is the word for female. So L1 means they try to minimize this. They try to minimize the difference between the vector of male and female. And the L2 here means they push both male and female vector to different space because E here is the one vector, B1 for male is 1 and for female is -1. This means that they push on the male vector to 1 and female vector to -1. And the last element is WA here. In, as I said before, for what there are two components. The first is a gender bias, is a gender direction, and the other is non-gender direction. So this the third components to make sure that other components will be orthogonal with the VG we calculate here. However, in the paper observed that the method before do not they just only they do not the gender bias all those maintain on the word embedding. So in this the main contribution of this paper is they do some experiment to verify that the gender bias is also on the word embedding after they do the debiasing method. So the setup they use to method before is the hard debias and the GN here is gender neural graph, and they compute the bias of a word by taking its projection to he minus c directions and using two sets of target word and attribute word to quantify the association between several words. So I will talk about this. The first one is they take the top 500 word male bias and female bias. They try to clustering the word, and the result show that for hard debias, the cluster has an accuracy of 92% when aligned with the gender compared to 99% with the original bias version. And for GN graph, the accuracy is 85.6% compared to 100% of bias version. This concludes that after the debiasing method, the word embedding also contains the information of gender in its word embedding. You can see that this is the draw of the clustering. So this is the original word embeddings before the debiasing, and for example, this is for gender, and the second is for other gender. So after debias, the clustering also maintains the gender bias on the word embedding. The second experiment is they measure the gender bias by the percentage of male and females that is socially matched among canary neighbors. So they found that for hard debias appears in correlations of nearly 0.7, and for graph is more than 0.73. This means that also in the nearest neighbor, the gender bias is also contained in both word embedding. The third experiments is they take some professional word and just plot it as of the y-axis. Here is a number of female word in the canary neighbor, and the second is the a bias correlation on gender directions. We can see that when the bias to males increase, the number of words in the that is male socially matched is also increase, and you can see that the word here is a professional for male, and this is a professional for female. And this experiment also concludes that for the professions word after devising the gender bias, they also contain in the word embedding for professional work. The first study is they evaluate the associations between female and male names with the families and career work, the females and male concepts with arts and mathematics, and the association between male and female concepts and arts and science works. So in this paper, for female concepts and male concepts, is they use both the female name because some example of female name here, male names, family words, career words, art words, math, etc. here. And also the formulas is here is still quite straightforward, so I do not talk about this. But in the thing here is in the formulations, in the observations, they found that females is more associated with family names, and the male names is more associated with career works. The female word is more associated with the art than the male word to mathematics. And the last is females is more associated with art than the science. So it so can we see that for science and math, and also the gender bias is also contained in the male and female word. And the final experiment is they try to classify the previous male and female bias word. They change an RBF-based kernel SVM classifier to classify the word after debiasing before and after debiasing the gender bias. So for hash debias, they achieve an accuracy of 88% compared to more than 98%. And the similar observations if for GN class, they also conclude that the gender bias is also contained on the word embedding. And finally, there's some conclusions about this paper. The first one is words with a strong gender bias are so easy to cluster. After the words with the gender from social stereotypes, means like receptionist, hairdresser, captain, etc., tend to groups with other implicit gender, like in the professions diagram you see before. And the last one is the implicit gender words are very easy to based on the vector alone. And the final point I want to make sure is I want to talk about is the popular definitions that quantify gender bias on gender direction is not enough. So is needed to other informations and other aspect of the gender, also others to the bias need to be considered to debias the word in that embedding. So that's all from my presentations. Do you have any questions?